tripod, and the tripod can hold the camera, can hold the light, but unfortunately it cannot hold my smartphone. So let's solve this problem. So I look up the standard of the screw, which is a 1/4 inch with 20 advances per inch. In millimeter, this is 6.35 outer diameter and 5.11 inner diameter. As we cannot really use the exact values, we have to add a little bit to make the screw actually work. I add 0.65 millimeters, and the total diameter then will be 7, respectively 5.76. I divide that by 2 so that we have a radius instead of a diameter. The same goes with the advance, and finally we have our values for the 3D modeling. I use AC3D, my preferred 3D modeling program. We'll fire up that now. Well, actually it's fired up already. Come on, click. Yeah, here we are. And I use these values to create a triangle. Adjust the coordinates manually via an input you cannot see, unfortunately. And I revolve that triangle 5 times, 5 terms around the y-axis, and here we have our screw. Of course, now there are a lot of leaky surfaces, that means surfaces which are not connected. So what I do is I select all the vertices and snap them together by distance and simplify or optimize the object. And as you can see, only the top and the bottom are now opened surfaces. Now I select all the lower vertices near the bottom, pull them down into a plane and extrude the edges. As you can see, it's not perfectly centered, so I correct that a little bit. And do these extrude edges again to form the outer hull of this of the screw, or the nut actually. I just pull them up so that this inner construction is covered, and the top will be thick enough so that we have a little bit of a stability. And here we have, yeah, kind of a nut. The top surface will be combined so that we have only one surface instead of a lot of triangles. That makes the job easier afterwards. Now that we have this the top one surface, I'm gonna use this the knife function, which is really nice. With knife you can slice an object into separate objects, or just slice the surfaces of an object. I will use the latter one multiple times, so I get more than one surface, or the top surface, cut so that I have some surfaces which I can extrude to the top, which will form the handle for the phone. Do that a little bit quicker because I had to measure the distance from time to time. And finally we have 2 surfaces which I can use to pull up, to extrude up. My phone is not perfectly flat. It's thinner at the edges and bulges in the middle, so I try to adapt that, and again some measuring how far the distances, the vertices are apart. The distance is shown in the upper right corner in AC3D. Push them in, push them out a little bit, make all that a little bit thicker, a little bit thinner, and so on until I'm satisfied. Of course, I also made sure that the height is enough to hold my phone, and that the distance at the very top matches the thickness of my phone. Yeah, at that point. Finally, I use this knife function again to add a little bulge inwards. So again, some vertex pushing. Yeah, that should roughly do it. And it looks nice. That should be good enough to hold the phone. It has not to be that exact on a tenth of a millimeter, because it should have some play anyway. Yeah, and that's a clamp. What I should always do with 3D modeling for a 3D printer is check for leaky surfaces. The surfaces have to be closed, because otherwise the 3D printer will have a problem creating really a 3D object. It cannot be open at any point. And as you can see here, I forgot one thing, and that is the top of the thread. So let's close that again. So what I do is I zoom in, select some surfaces, then do a loop select, create a surface out of these vertices. The next important thing is that the normals are pointing outwards for each surface. That is also quite important for 3D modeling in general, and especially for a 3D printer, so that the slicer that we will use in any minute knows what is an outside, what is an inside. AC3D shows the normals with a very thin pink line, which may or may not be visible in this video. I think it's hard to see, but if you want to try AC3D, you will see yourself. So now that all the surfaces are closed, except some very minor at the very bottom of the thread, which I don't really care about now, we have our final model. I tried to close this with making a triangle and simplifying the object again, and snapping the vertices together and so on, but I figured it's good enough for the printing. So we can export that, and I use this STL-ASCII format, which is one of the input formats that Cura can work with. Cura is the slicer that will produce the layers that the 3D printer then will use to extract the filament onto the printing plate. So I import that file, and we should then immediately see how this object will look like. By the way, it closes some surfaces as well, so it will correct the minor imperfections that I left. It will be 28 minutes and using about 2 grams of filament. These are the dimensions of the object. And I will print at 0.1 millimeter layer height with 50 millimeters per second and at 210 degrees. Now this is coming directly from the 3D printer, and let's see if it fits. Yeah, it fits, and it can hold my smartphone. As you can see, I'm a bit proud. I hope you enjoyed this video and see you next time.